we got cut off in the middle of our video. So we'll pick up from where we left off. So we made all of our exponents positive. We moved our 2 to the 4 up. We moved our 2 to the 8th down to make it positive. We moved our x to the negative 5 up and our x to the negative 2 down. And then finally we left the last two because they were already positive as is. And then we're going to apply the quotient rule. If you look back, sorry to jiggle the paper around. If you look back, the quotient rule says keep the base the same, subtract the exponents. So that's what we're going to be doing here. Keep the base the same. And remember, subtraction of exponents is important, the order. So it's 4 minus 8. Don't write 8 minus 4. It's numerator minus denominator. So there's 2 to the 4 minus 8. And then our x is going to be x to the 5 minus 2. And then our y is going to be y to the 3 minus 6. So now we subtract those and we get 2 to the negative 4. 5 minus 2 is x to the 3rd. 3 minus 6 is negative 3. But remember the rule. Right now it's over 1. The rule says we're never allowed to leave negative exponents in an answer. So right now they're over 1, so I circled the 2 factors that have negative exponents, and remember they have to move to the other side of the fraction in order to make them positive. So the x to the 3rd is already positive, so it stays exactly where it's at. But the other 2 must come down, so this will turn into 2 to the positive 4 when I bring it down, and this will turn into y to the 3rd when I bring it down. And then the only other thing we have to do is work this out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this would be x to the 3rd over 16, y to the 3rd. And there we have it. Okay, so like I said, these get a little bit tougher. So this next one I put on because a lot of students make this problem on the test, and this one is on the test, a lot harder than it has to be, and it's because they don't do parentheses first. We always do parentheses first, which means make your exponents positive. If there's any simplifying, do that. So first, work on that. I think I'm going to put this on a separate sheet of paper just so we have enough room here. So I see that I can simplify. 3 goes into 3 once. 3 goes into 12 4 times. And then I also see that this x needs to move down. This one stays put. And then I see this, y to the negative 2 over y to the negative 2. Guess what? That cancels. Anything divided by itself is 1. It doesn't matter if the exponents are positive, negative. So y to the negative 2 divided by y to the negative 2 is 1. And then this z needs to move. So I guess we probably won't need an extra sheet of paper for this. So now what I have is 4. In the numerator, I'm going to just have z to the 4th with it. And then this z to the 4th needs to move up to become positive. So 3 went into 3 once, 3 went into 12 4 times. There's where I get my 4. The x to the negative 3 needs to move down, so I'm not going to leave it in the numerator. The y's canceled. Z to the 4th is already there, but this z to the 4th needs to go up to make it positive. So now I have the z to the 4th that was already there, and this z to the 4th up with it. In the numerator, I have the 1, which I don't need to write, and then I have x, and I'm just going to put an exponent on it. It's x to the first, and this x needs to move down, so that becomes x to the third, and this z already went away and went up there. So maybe we should have these circled so we know that they have to move rather than underlined. So those two had to move. This one had to go up. That one had to go down. That way you can kind of see where they went. So the y's canceled, x to the third went down, z to the fourth went up. And they stayed right there beside the exponents that were already positive. So the exponents that were already positive did not move. That's why x to the first stayed in the denominator and z to the fourth stayed in the numerator. So now we have a really simple problem. So the answer is going to be 4. What do we do in multiplication? We'll look at page 1. In multiplication, we keep the base the same and add the exponents. So that would be 4z to the 8th over x to the 4th. Done. So that looked like a lot more complicated problem than it actually was. But the key, like I said, was knowing to simplify in, Kim, I'm losing my touch here. So that's simplified. Now we still have the -3. Forgetting a whole step here. So when we have a negative exponent, remember that means we need to reciprocate the base to make the exponent positive. I knew this one was longer than I was giving it credit for. 4z to the 8th, and now the exponent's positive. So the key on this, as I was saying, is to remember to do anything you can inside first. Simplify your fractions, move your exponents to make them positive, cancel if you have something divided by itself. Then worry about this. So this is way at the end, but don't forget about it like I almost did. Okay, this paper keeps flying in my way. So we simplified the inside, 4 plus 4, 8, 3 plus 1, 4, but then we have the negative exponent, so to make it positive, we flip the fraction. It would be just like this one we did on the front page. To make that exponent positive, we reciprocated the base, then the exponent's positive. So that's exactly what we did here. We reciprocated the base, exponent's positive. Now we just have a quotient rule. So we need to multiply all of our exponents by 3. So this is going to turn into, running into 4 times 3, 12. So x to the 12th over 1 times 3, 4 to the 3rd, 8 times 3, z to the 24th. So that would be x to the 12th over 4 times 4 is 16, times 4 is 64, z to the 24th. So once we make the exponent positive by reciprocating the base, then we distribute that 3 to all the exponents that are inside. So 4 times 3, and remember the power rule says multiply the exponents, so 12, 1 times 3, 3, 8 times 3, 24. And then we just have to work this out. 4 times 4 is 16, times 4 is 64, and then z to the 24th. So I have 2 of these on your test, and 14 and 15 are the best ones to study. So you really want to work hard on this section in Alex, because like I said, this is a tough section for students. Very tough. Okay, so let's go ahead and look at this last one on this page. So What a lot of students do wrong on the test is they take this 2 and they just distribute it everywhere. It only goes with this parenthesis. It does not go with the first one. So if I have anything inside that doesn't have an exponent, remember how I said it's kind of nice if you put the ones in so you don't forget them, because that's common. Students will multiply the exponents that are there and then don't remember that those are ones, and they get multiplied with the 2 as well. So because there's no exponent or anything here, this is really just going to come down. It doesn't even need the parentheses. So we can drop the parentheses and just bring it down. So it'd be negative 3x to the 5th y to the negative 6 times, because 2 parentheses side by side just mean times, and then this one will be 5 and raising to a power. Remember, when we raise to a power, we multiply our exponents. Up too high. M to the nth power is m times n. So 1 times 2 would be 5 to the second. Negative 1 times 2 would be x to the negative 2. 1 times 2 would be y to the second. So now we have negative 3x to the 5th, y to the negative 6th, times 5 times 5 is 25, x to the negative 2, y to the second. And now the hard work is done, because now it's just a simple multiplication problem. So we multiply our coefficients. Negative 3 times 25 is negative 75. And according to the multiplication rule, we keep our bases the same and we add our exponents. So add the exponents. So we're going to do the same thing here. Keep the base of 5. 5 plus negative 2 would be 3. Y, negative 6 plus 2 would be negative 4. So we multiply the coefficients, add the exponents. 5 minus 2, 3, negative 6 plus 2, negative 4. So are we done? One more step. Remember, we're never allowed to leave negative exponents. So any base that has a negative exponent needs to be moved to the other side of the fraction. So that becomes negative 75, and this doesn't have a negative exponent. It's a negative number. There's a big difference. Its exponent is 1. So negative 75. This one doesn't have a negative exponent, so it stays put. And then this becomes y to the 4th. And there you have it. And that was one of the most missed problems on the test last semester. Might have been the most missed. So both of those really good ones to study for the test. Okay, let's go over scientific notation rules, and then we'll start on our back page. So scientific notation is when a number is expressed as a whole number times 10 to the nth. And n must be an integer, which means positive 1, negative 1, positive 2, negative 2. So those are the kinds of numbers the exponents must be. That's n. And then a has to be between 1 and 10. That is huge, huge. So a has to be between 1 and 10. So, for instance, to write 120 million in scientific notation, right now, 120 million's decimals right there. because when there isn't a decimal in a problem, we can assume that means it's at the end. So we'll pick